Welcome back. You know, if you're working with IoT devices and the Zephyr RTOS, getting them all to talk to each other is pretty much the whole game. So today, we're going to do a deep dive into one of the most popular protocols for exactly that job, MQTT. So what even is MQTT? Well, at its heart, it's a super lightweight messaging protocol. It was designed from the ground up for machine-to-machine communication. You can think of it like the perfect postal service for your IoT devices. It's incredibly efficient, it's reliable, and it's built for those tough spots where bandwidth and power are really precious. And that's the million-dollar question, right? It's one thing to know what it is, but actually getting it up and running in your code, that's a whole other story. And that is exactly what we are going to break down right here, right now. All right, here's our game plan. First, we're going to get the why behind MQTT. Then we'll meet the core players that make it all work. After that, we'll see how Zephyr's built-in library makes our lives easier before we jump right into the code to build a client. And to wrap it all up, we'll cover how to secure the connection and then put all the key pieces together. Let's get into it. Okay, first things first. Let's really understand the fundamental ideas that make MQTT just so perfect for the Internet of Things. These four things right here, this is where the magic happens. Being lightweight means it's perfect for those tiny, battery-powered sensors. Now, the publish/subscribe model, that's a total game changer. It means a sensor can just shout its data out and it doesn't have to know or care who's listening. This decoupling is what makes it so scalable for these big machine-to-machine networks. And it does it all while running on the good old reliable TCP/IP stack that we already know and love.
You know, every single MQTT setup, doesn't matter if it's big or small, has three essential components. So let's meet the players.
First up, you've got the client. This is your device out in the wild. The sensor, the light bulb, the thing actually doing the work. It can be a publisher sending out information, or it can be a subscriber listening for commands. Sometimes it can even be both.
Sitting in the middle of everything is the broker. This is your central server, the post office. Its only job is to receive all the messages from all the publishers and make sure they get routed to the correct subscribers. It's kind of like the traffic cop for your entire IoT network.
And finally, how does the broker know where to send everything? It uses topics. A topic is really just a simple text string, maybe something like home/living room/temperature, that acts like a channel. A client publishes a message to that topic, and any other client that's subscribed to that exact same topic gets the message. It's so simple, but it's incredibly powerful.
Okay, so that's all the theory. How does this actually translate into our Zephyr project? Well, I've got good news for you. Zephyr makes this incredibly easy. Zephyr comes with a native MQTT client library baked right in. All you have to do is go into your project's kconfig file, which is just Zephyr's menu for turning features on and off, and set config MQTT lib. And bam, just like that, you have all the tools you need right at your fingertips. All right, let's get our hands dirty. We're going to walk through the 5 key steps to get your very own MQTT client up and running in Zephyr. First things first, we need to set the stage by setting aside some memory. This means we're going to create a buffer for incoming messages, one for outgoing messages, and most importantly, we're going to define this MQTT client structure. You can think of this client CTX variable as the brain of our whole operation. It's going to hold all the configuration and state for our client. Next up, we create our event handler. See, the Zephyr MQTT library works asynchronously. That means it just notifies us when something important happens, instead of forcing us to constantly ask, is anything new? This is perfect for an RTOS because our code doesn't get stuck waiting around. It can go to other things. This callback function is where we're going to handle all those notifications, like when we get connected or when a new message arrives. And this is a great look at the kind of events you'll handle. Connack is the big one. That's the broker saying, hey, welcome, you're connected. Publish lets you know that a new message has just arrived on a topic you're subscribed to. Pubback is a confirmation that a message you sent was actually received. And, well, disconnect. That one's pretty self-explanatory. Now we start putting the pieces together. First, you call MQTT client init on that context structure we made. Then you just start filling it in. You point it to the broker's address, you tell it which function to use as your event callback, the one we just made, and you give your client a unique ID so the broker knows who it is. With everything all configured and ready, it's go time. A single call to MQTT connect, passing in your client context, is all it takes.
This one function handles everything, creating the socket, establishing the connection, and sending that official MQTT connect message to the broker.
Okay, so once you're connected, the work isn't totally over. You have to keep that connection alive. In your main application loop, you'll need to call MQTT input every so often to check for incoming data, and you'll need to call MQTT live to send out a little heartbeat ping so the broker knows you haven't disappeared. Now, everything we've talked about so far is fantastic for testing on your desk, but for a real-world product, security is absolutely non-negotiable. So let's see how easy Zephyr makes it to build a secure connection using TLS. And here's some more great news. The Zephyr library makes this unbelievably simple. To enable a secure TLS connection, you just change one little field in your client configuration, from MQTT transport non-secure to MQTT transport secure. Seriously, that's it. Of course, it's not quite magic. You do need to provide a little more info. You'll want to set peer verify to make absolutely sure you're talking to the right server. You'll provide the broker's hostname to validate its certificate, and you'll point to a sec tag list. And that list is just Zephyr's way of referencing the cryptographic keys and certificates that you've already safely stored on your device. We've covered a ton of ground, from the big ideas all the way down to the code. So let's zoom out and just summarize the essential functions that really form the core of any Zephyr MQTT application. So here it is, your 5-function cheat sheet. You init to get everything set up, you connect to get online, and you publish to send your data out to the world. Then you just keep the engine running in your main loop with calls to input and lib. Honestly, these 5 functions are the heart and soul of any MQTT application you're going to build in Zephyr. And there you have it. A complete blueprint for getting your Zephyr device connected to the world using MQTT. You have the tools, you have the knowledge, and you've got a secure, reliable foundation to build on. So the only real question left is, what are you going to build next?